Okay, let's look at example 4. The path of a particle given for time t is greater than 0 is defined parametrically by x equals t plus 1 over t and y equals negative 6t squared. For part A, it says find values of time t for which the particle is moving left. So if you don't already know this, then it's important that you remember this in the future, because this asks a lot on tests. I actually had this question or something like this on one of my tests. So when a particle is moving left or right, it means we're working with dx dt. And that makes sense because the x-axis is horizontal. It's moving left and right? And when a particle is moving up or down, that means we're working with dy dt, because the y-axis moves up or down, or vertically, right? So you just need to know that a particle is moving left when dx dt is negative. It's moving right when dx dt is positive. It's moving up when dy dt is positive. And it's moving down when dy dt is negative. And another really important thing to remember is that if it asks you when a particle is stopped or at rest for a parametric equation, that's when dy dt and dx dt are both equal to 0. So make sure that they're both equal to 0, not just one of them, because if it's only one of them and not the other, then the particle isn't stopped. So just keep in mind that this means that the particle is stopped or at rest. Okay, so let's look at 4a. Find values of time t for which the particle is moving left. So remember, the particle is moving left when dx dt is negative. Is less than 0. So first off, we have to find dx dt by taking the derivative of this. So dx dt is equal to 1. Let's actually rewrite x to be that t to the negative 1. So the derivative of that is minus t to the negative 2. And we're trying to see when this is equal to 0, so that we can do a sign test and check when it's negative. And when we rewrite this and solve for t, so you get t equals plus or minus 1. But in the problem, it says that t has to be greater than 0. So that means we can knock out t equals negative 1 and just look at t equals 1. So this we have to do a sign test to see when dx dt is negative. So we're not looking at values less than 0. We're only looking at values of t greater than 0. And t equals 1 is our critical point, so now let's do our sign test. So if we pick a value in between 0 and 1 of t, let's say t equals 1/2, and we plug in 1/2 into dx dt, let's do that. 1 over 1/2 squared is 1/4. So we're going to get 1 minus 4, which is negative 3. It's negative. Then when you plug in a value of t greater than 1, let's say plug in 2, then you get into here 1 minus 1/4, which is 3/4, and that's positive. So what we were trying to find was when dx dt is less than 0, and that occurs between 0 and 1. And this is less than because it says when t is greater than 0. Okay. Okay, for 4b it says find the speed of the particle at time t equals 1. So the big thing I want to emphasize is that it says parametrically. So whenever we're dealing with parametric equations, it's different from our normal equations, because our normal equations don't have the t in it, it just has x and y. So for parametric equations, there's a formula for speed, and it's the square root of dx dt squared plus dy dt squared. And you probably do need to memorize these, or this formula. Whereas in a non-parametric equation, a lot of people do this like on tests, they forget this and think that the speed is the absolute value of velocity, which is true for non-parametric, but when we're dealing with parametric, we gotta remember this formula. So in our problem, we have to find dx dt and dy dt, and it says at time t equals 1. So let's find dx dt. And let's rewrite x. So it's t plus t to the negative 1. Derivative of that is 1 minus t to the negative 2. And dy dt, if we look here, the derivative of y is negative 12t. So according to our speed formula, it's dx dt squared plus dy dt squared, and that whole thing to the square root. So 1 minus, I'm going to rewrite it as 1 over t squared, that whole thing squared, plus dy dt, which is negative 12t squared. And it says find the speed at time t equals 1. So now all we have to do is plug in 1 into t. And when we do that, we get 1 minus, well, 1 over 1, it's just 1. When we plug in 1 into here, just get negative 12 squared. So we're left with 1 minus 1 squared, that's just 0, and negative 12 squared is a positive 144. And the square root of 144 is 12. So that's the answer for part B. Alright, 4C. Set up but do not evaluate the integral expression for the total distance traveled by the object from x equals 2 to y equals negative 24. So for non-parametric equations, you might remember that the total distance formula is the integral from a to b of the absolute value of velocity. But for number 4, it says parametrically, and the formula for total distance for a parametric equation, and you probably want to remember this, is the integral from a to b, these are time t values, of the square root of dx dt squared plus dy dt squared dt. So we're not going to use this formula because we have to use this one for parametrics. So remember from part B we found that dx dt equals 1 minus 1 over t squared and dy dt equals negative 12t. So we're asked to find the total distance traveled by the object from x equals 2 to y equals negative 24. And it says do not evaluate, just set it up. So the total distance is the integral, and these should be t values, but notice that they give us x equals 2 and y equals negative 24. That's a bit weird, but what we can do is actually use these equations and plug in these values to see what our a and b is. So let's do that. So x equals 2. Let's plug that in. So 2 equals t plus 1 over t. And let's solve for t. I'm going to multiply everything by t to get rid of the denominator. So 2t equals t squared plus 1, and t squared minus 2t plus 1 equals 0. And then I'm going to factor this out, and we get t equals 1. So we found the value of t when x is equal to 2. Now let's find the value of t when y equals negative 24. So we got to set negative 24, which is y, equal to negative 6t squared. So when you divide negative 6 by both sides, you get t squared equals 4, and t equals plus or minus 2. And since it says t is greater than 0, then we can get rid of this guy. So we have from t equals 1 to t equals 2. Originally it said from x equals 2 to y equals negative 24, and that was just to throw us off. But now we have our a and b. So the smaller one's going to be a and the bigger one's b. So the integral from 1 to 2. These are t values. Alright, so the square root of dx dt squared, so dx dt is that, so 1 minus 1 over t squared, that whole thing squared, plus dy dt, is negative 12t squared. And we're done because it just says set up, do not evaluate. So cool.